Topic which I have selected for demo part is volume of solid of revolution. So before going towards the volume part, I first want to discuss what is solid of revolution. So to discuss what is solid of revolution, I need a function y is equals to f of x. This is bounded by this domain. What I need is this. First I sketch this particular function. I need a bounded region. I will revolve that particular bounded region about some given axis. After revolving that particular bounded region about some given axis, the resultant produced body is known as solid of revolution. If I sketch this particular function, for example, if this point is A and this point is B, and the given function f of x is defined over here, this is shaded region is known as the bounded region, which is bounded by the function y is equals to f of x, the x-axis y equals to 0, the line x equals to a and x equals to b. So these four different functions, y is equals to f of x, y equals to 0, x equals to a and x equals to b, bound this region. What I do is this: I need a solid of revolution which is obtained by revolving this bounded region about axis of currently I just revolve this particular bounded region about x-axis. So after revolving it about x-axis, I'll get something like this. Now this resulting body is known as solid of revolution. The task is to get the volume of this particular solid of revolution. So to get the volume, what we do, we just slice this particular solid into several discs. And getting the volume of one disc and then integrating the whole region between A and B will get the final volume of that particular solid of revolution with the help of this method. So for this method, initially I need to know what is a volume of a circular disc. The volume of a circular disc is pi into radius square into thickness. Now what is radius and what is thickness? I take one slice of a disc from this particular solid of revolution. For example, if this is the disc removed from this solid of revolution, this particular is known as radius of disc, and this much is thickness of disc. So taking thickness and radius square multiplied by pi, I'll get volume of one circular disc. So integrating this over the whole region between A and B, I'll get the volume of the whole solid of revolution. So for this I need one example. For example, I have a bounded region which is bounded by a parabola the x-axis y equals to 0, a line x equals to 1, a line x equals to minus 1. So if this whole provide me the bounded region, which is this point x equals to minus 1, x equal to 1. When I take x to be 0, y is 1. So here, for example, let's say y is 1. If I plot it, a parabola, this whole region is y equals to 0. This is x equals to 1. This is x equals to minus 1. And this is x squared plus 1. So with the help of these curves, I get this bounded region. Now, the point is this: I need a solid of revolution which is obtained by revolving this particular bounded region about x-axis. Not necessarily that I take x-axis. This, for example, I'm taking x-axis. I can revolve this particular about any line, about any other axis. So, for example, currently if I'm revolving it about x-axis, the bounded region is about this particular x-axis. The resulting bounded region, the resulting solid of revolution is this will result out after revolving this bounded region about x-axis. This is known as solid of revolution. Now the target is to get the volume of this solid of revolution. According to this method, the volume is so one circular disk's volume is given by pi radius square in thickness. How I relate this dx and this f of x with radius and with thickness? The idea is this: I divide this particular solid of revolution into several disks with this much thickness, with this much radius part. If I take one disk out, so this will give me the radius and this will give me the thickness. If I check here, what is this? This is one of the disks, and this length will represent the radius. How I get this radius? This function, which is y is equals to x squared plus 1, this point, which is y equals to 0. So the difference of this fx and this 0 is the radius of this particular disk, and its thickness is this much. The dx thickness, the difference, the very small difference, to take a very small slice of that particular disk. So according to the given example, the radius part is x squared plus 1 minus 0, which is into dx, the radius squared into the thickness, from A to B. So in our current example, from -1 to 1. So from -1 to 1. The result of this particular integration will give me the volume of that particular solid of revolution, which is generated by revolving this bounded region about x-axis. So solving this integral, integrating it, applying the limit of integration, I will get finally 2 pi simplifying this constant value. I'll get the final volume of solid of revolution, which is this. Solid of revolution obtained by revolving this particular bounded region about x-axis. So with the help of one disk volume, integrating it over the region -1 to 1, I'll get this answer, which is known as volume of solid of revolution. Thank you.